Okay, we are discussing about the variables, static variables and instance variables. So I think you have got a faint idea about what is static variable and instance variable. Okay, static variables belong to class, they do not belong to the object, whereas instance variables, they belong to the instance. Okay, there is only one copy of the static variable which will be shared by all the instances, but every instance will have its own copy of instance variable. Okay, so this is how they have designed it. Little we go deeper into the memory also today, and we'll see how things are handled in the JVM. And you know why static variables are used now? Static variables are used for what purpose? If a single value is needed to be shared by multiple instances, you can use the static variable. A single value will be needed by multiple instances. Okay, that time you can go for what? Static variables. You can take that option. Okay, example for that. Okay, example we saw like see like this class. You can take student also, anything you can take. You can have int student ID, then you can have string name, they can have int marks 1, int marks 2, int marks 1, int marks 2, but something like past marks will be there, no? They can have something like string college. Okay, college is a variable of type string. So this is a common value for all the students. So that time you can make it as static, and you can provide the value here, like what area college. I'll just write VTU. It's not a college, it's a university, but just I told. So all the students belonging to one college will have only one value. So you can make it as static and give the value. Clear this? So this is one way how you can have static variables. So these values will differ from student to student. See how it will differ now? Student S1 is equal to new student. I am writing shortcut. S means student. Student S1 is equal to new student. Create the object. In S1 these four values will be different. In S2 again the values will be different. But in all the objects college will be same. Are you following this? So it helps you in very good memory management. Static variables helps you in very good memory management. Okay, optimum memory management. Same value will be needed by multiple instances. Are you understanding what is same memory needed by multiple instances? I am not initializing S1 here, but you understand now. S1 will have what values? If you provide, SID will be 101. He can have his name as AAA. You will provide it. We will see how to provide it. You know how to provide. Okay. So then you can have int marks 1. Marks. He'll have his 66. He'll have marks 2. Marks 2 which is 55. But college will be somewhere outside VTU. Then this is one object of student. You'll have another object of student now, S2. SID is equal to 102. Means you can assign it with dot operator. S1 dot SID is equal to 101, hard coding, dot operator, anything. Okay. But every instance you create, those many instances variables will come into existence. BBB marks is equal to, you can have his own marks, 45 marks to 92, something like this. But both of them will share the same value of college. Are you getting it now? So these are the things will be organized. Are you clear? So there will be only one copy of the static variables. There will be only one copy. But instance variables, how many copies will be there? Depends on the number of instances you create. Okay. Now one more thing. How many different ways are there to initialize instance variable? 4. Hard coding, dot operator, methods, constructor. Okay. If you want to initialize static variables, now how many ways are there? 4 ways are there. Same 4 ways. Hard coding, dot operator, okay, constructor, method. But we prefer to hard code. We prefer to hard code and initialize static variable. We never prefer to initialize with other 3 approaches. See, are you clear with this topic now? So let's see now. I clear it off. So initialization, we'll see now. So what are the different ways you can initialize? Initialization of variables. Which 2 variables? Instance and static. 2. First one. So one is hard coding now. So first way you can initialize your instance variable is by hard coding. Hard coding can be done in what way? Two ways. You can do while declaring a variable. Means hard coding, you can do it while declaring a variable. You'll be declaring now class box int w is equal to 1. This is why declaring only you can initialize it. Or another way is you can initialize hard coding only, but you can hard code in instance block. Two ways. Is it visible? One second, I'll write it still more clearly. Heading is this, instance and static. Instance variable, static variable. In hard coding there are two ways. While declaring a variable you can hard code, or two, you can hard code in instance block. Any approach. Okay. Second one, we can assign value with dot operator. Or it's better we don't do it like this. Then third one, you can assign, means you can, second one is assign value with dot operator, third one is methods, fourth one is constructor. These are the four ways you can initialize, but we prefer to do this way. I'm not saying all are incorrect, these are the possible options you have, but preference is given more to constructor. The same way in static hard coding. Hard coding where you can do same thing while declaring a variable. Then second one is hard code in which block? Static block. You can hard code it in static block. See, even if you initialize it in a block, you know whether it is static or instance. This is block now. I can say, see here, int h, I declared a variable. H is equal to 5 means this is hard coding only now. Can I send a dynamic value? No, that's hard coding only. Okay. So let it be static or instance, but that's one more kind of hard coding only. But you are doing it in block. Here what the difference between initializing here directly means as soon as it comes into existence, it will have the value. But if you hard code in a block, first it will come to existence, it will have default value. When the block gets executed, it will be overwritten. See h, when it comes to existence, what will be the default value? 0. Okay, afterwards it will be overwritten to 5. But w is not like that. As soon as it comes into existence, it will be initialized to 1. That is the difference. Okay, so now this is one way. Then second one is what? Assign value with what? Assign value with same dot operator. Third one, methods. Fourth one is constructor. See, you can initialize static variable also in these four ways. But we give preference which one here? First one, hard coding. Even though you can do it in all the ways, because if you use any of these approaches, there is possible chance of overwriting. And the same, but here the problem is if it overwrites, all instances will be expecting the same value. So they do not want the value to be modified. Okay, so that's the reason we prefer it with hard coding. Are you clear with this now? Any questions here? How do you initialize? Now let's see little about memory also. How things are getting handled in the memory. Where your instance variable is stored, where is static variable stored, where is local variable stored. All that we'll discuss today. Or we'll clearly means today we'll put the final nail into the coffin. Difference between static variable, local variable and instance variable. It will be very clear to you today. After these many days of hard work, very clearly you will understand the difference between these three variables. Do you have any questions here? Do you have any questions here? No, no? Shall I move to the topic now of memory management? Okay, like how things are allocation of memory for variables. The next topic is allocation of memory for variables in JVM. Shall I clear? Clear now? And hard coding of static variables can be done anywhere. while you are declaring a variable, or you can do it in a static block also. Either option correct, both are correct. One situation will do it in one way. And we are going to use all this practically. Be aware of all this. What all ways you can work and all, be aware. Okay, see, I'll write on simple class now, and let's see how it will be handled in the JVM now. I'll write on static int A is equal to 5, int B, I'll just declare a variable. Then I'll have one M1 method. Or 1 second. I'll name these variables as X and Y. One variable by name is there called as X, another variable by name is there called as Y, but difference is X is a static variable, Y is a instance variable. Fine. So then I'll have one method void M1. This method, say, it can use, or I will declare one more variable here. Int M is equal to 7. Any value you want you give. So what is M now? See the difference you can see, notice now. We are discussing, the topic is allocation of memory for different type of variables in JVM. This is the topic. Keep that in mind now. Okay. Where and all it will be allocated, how is memory managed, all that we'll discuss. So if you notice here, X is what? Static variable. Y is instance variable. M is what? Local variable. Okay. So then see your local variables. You see, for this example, you have to write one more class called as box. So now if I write class called as box, okay, so box B is equal to new box. So I can use my user defined data also as what? Local variable. This is perfect. This is 100% valid code. Understood? Till now you are writing all the code in main method now. In main when you write the code, what are all there? They are all local variables only. Okay, so when you can have, see, if you are having a data type, remember that. Okay, if you are having a data type, the data type can be used in any manner. You can use it as local variable, you can use it as argument, you can use it as parameter, you can use it as return type, all that we have seen now. Now we are focusing on more on user defined data type as local variable. Okay, so this is also correct. We have done this coding earlier, it is valid. Understood? And now this method can use all the type of variables. What all variables it can use? Static variable it can use, instance variables it can use, local variables it can use, this type of local variables also it can use. So let's see how it works now. So SOP X valid code, SOP Y valid code, box B is equal to new box off. What I'll say is 1, 2, 3. I'll create an object like this. Okay, then SOP M, I can print SOP B.W, B.H, B.D, all this. So I'm working with all the type of variables here. Yes or no? So this is your program. A very simple class here. One static variable, one instance variable, and one method. Okay. Then we'll do one thing. We'll have one here the place will be insufficient. Okay, I'll write it here. Class, this is the title. Class demo. This will have public static void main string args. So we'll try to use this class now. Which class I'll try to use? Hello class. Let's see what happens. So I'll write hello h is equal to null. Hello h1 is equal to null. I'm only declaring a variable. And next I'll say hello h2 is equal to null. Then after declaring the variable, I'll create the object. h1 is equal to new hello, h2 is equal to new hello. And if I'm interested, I can initialize the values. h1 dot y is equal to 10, h2 dot y is equal to 20. I'm giving the values. After that, I can call the method h1 dot m1, h2 dot m1. You know how it works. There's no problem with all this. Okay, but what I'll be showing you just now is like how the memory is going to handle these things in the JVM now. Okay, so let's see in JVM what all happens. So this is our code now. Okay, so generally what happens, if you want to run this program, you will type the command as what? What is the command you will be typing? You will compile. See, there is a difference between writing a source code and getting it executed. So when you write the code like this is source code, and you will be keeping it in demo.java. Okay, so demo.java is a source file which cannot be executed because the processor cannot understand high level code like this. Okay, the processor can understand only binary language. So why are we learning? We are not learning binary. It is very difficult for us to learn binary and code. That is the problem. So we are learning some easy languages where we can code easily and then get executed. So there are many high level languages. One of the high level language you are learning is Java. So when you learn this high level language, we will learn. I can understand, I can code, but the problem is machine cannot understand this language. So due to that problem, we have to compile. When you compile, what happens? You get two dot class files generated here. In one file, you are having two classes. In fact, three. Box also is there. So you'll find three dot class files. Hello dot class, box dot class, demo dot class. Okay. So like this, all the dot class files will be created. So it is a dot class which is executable here, not dot Java. So first you have to compile. Okay, first you have to compile. After compiling, dot class files are generated, and these are executable files. To execute now, okay, one by one these classes have to be loaded into the JVM. One by one. You can't load all in one shot. Okay, so the first class which will be loading into the JVM is the class which contains the main method. The first class among all the classes, you have got three classes right now. Okay, in fact you are using so many classes. One you are using what? String is a built-in class. System is a built-in class. Our user-defined classes are three. Which one? Hello, box and demo. String and system are three user-defined class, two built-in class. So all these classes have to be loaded into the JVM. So one by one we start loading. Like that, plenty of classes will be there. Okay, but one by one we start loading all the classes into the JVM. Now, how do you load? First class. The first class which you'll be loading is now by using the command Java. What are the different ways you can load a class into the JVM now? One is Java command, second one is new, third one is when you access a static member. These are the three ways we have seen currently how the classes are loaded into the JVM. There's a difference between class getting loaded into the JVM and object getting created. Two phases that we'll be discussing today in depth. So the first class will be loaded now. Okay, so which class will you load first? Among all the classes, you will pick the class which has the main method. Understood? So you'll write now Java demo. Java is a command. This command, what it will do? It starts the JVM. After starting the JVM, now it will load demo.class into the JVM. If this class is found, it will be loaded. Else you get the error, no class definition found, error. But to load this class into the JVM, the class path variable will be used now. Okay, are you understanding it now? The class path variable will be used to load the which one? Demo.class. So you know how is your class path set? How is your class path set now? See, it's class path. This is the variable where we have got the class path variable which has been set in environment variables. You can set the class path in DOS prompt or you can set it in environment variables. But the value of that is important. The value given to this variable is important. So the JVM will be using the value. What is the value given? Semicolon dot, semicolon is one value, C drive, JDK 1.6, something we have like JRE lib tools.jar. Roughly I'm writing. I'm not saying this is perfect one. Roughly I'm telling you we are targeting tools.jar. Okay. So what happens when you start this? Immediately JVM has started. It will refer to class path. Now it will first it will check. Is there in the current folder is there demo.class? Yes. If it is found, it will load. If not found, it will check in tools.jar also. In both the cases it has not found, what it will do? No class definition found error will be reported for you. If it is found, it is loaded. So always when a class has to be loaded, it will be checking in class path. The first class gets loaded. Understood? Which one? Demo class. So when the demo class is loaded, are you getting the difference now? One is coding, source file, compilation, then loading. So this will be loaded. Now after the JVM loads the first class, in the first class, always JVM is going to look for only main method, nothing else. Your class containing main method can have other members. We have written earlier. Class containing main was having what? M1, M2, so many methods it was having. It will not care for any member. The only member what it will be caring is main. So that too with small m only, compulsory. Capital M also it will not see. Okay, so small m only it will search. Once it is searched, it will identify that and it will start execution. So main is the starting point of execution. There is still in detailed information about this which I will be telling you at the end of Java syllabus. Reason is we have to see many keywords. public, static, void and all. After that I can explain you fully. But yeah, this is a normal process now. So the class will be loaded into the JVM and main method starts execution. Now main method will see which starts off execution. Hello H1. Class is not loaded. You are only declaring a variable. Hello H2. Class is not loaded. But when I say H1 is equal to new hello, now hello.class is loaded into the JVM. Are you understanding now how one by one the classes are loaded? Okay, so hello.class will be loaded into the JVM now. So once it is loaded, fine. Class is also loaded and object also gets created. Of which one? Hello. Next time, only object of hello is created, but class of hello is not loaded. Then it will initialize the two variables. Okay, then you are calling a method. When you call the method now, M1 starts off execution. Now box.class is loaded into the JVM. Are you following now? Now box.class is loaded into the JVM. Now the object is also created. Then all this method will complete execution. As soon as this method completes execution, B is destroyed. It's a local variable, notice. M and B are destroyed. And as soon as B is destroyed, it is dereferenced. So in the beauty of Java languages, whenever before a memory goes out of scope, we don't have to bother. In other languages, if your memory is going out of scope, you have to bother about that, release the memory, all that headache is there. Here it will go out of scope, no problem. The object gets dereferenced or it gets abandoned. Okay, so now that object will be marked as dereferenced. So finally the garbage collector will come and collect that dereferenced object. That's how it goes on. Next, h2.m1. So again the same method gets executed. Again one more object of box gets created. Like this it will go on. So box object, many times what will happen? It will get created, it will get dereferenced, all that will happen. But hello object is not dereferenced. Why? See here garbage collection will not happen because it is still referred. So to give you a very clear idea about all this, I'll draw a diagram. Okay, the same process, we'll see it with a diagram, you'll get it with a clear idea. See, there are so many drawings you find in internet or in so many books, so many authors. End of the day, you don't look into the diagram, you look at the message from the diagram. Because one person will write the diagram in one way. I'll write one diagram today. You'll see another diagram somewhere. You don't go into the diagram. All of them are trying to interpret the message. Whether I am explaining and author is explaining, it doesn't matter. They are trying to give you one message. For us, the message is important. Message means what? How things are getting executed. The concept is important. So when you read books, read like that only. Do not bother too much about the memory. Diagrams also. Okay, do not bother too much about memory also. At the same time, do not bother too much about diagrams also. Why diagram you should not bother? One person will draw it in one way. End of the day, the extract of that is important for us. Extract means message of that. Clear? So let's see what all happens now. So Java demo. Are you following now? One by one the classes getting loaded, objects getting created. Okay, fine. Let's see now. As soon as you say Java demo now, what happens? See, this will be the JVM diagram now. Roughly I am drawing it. So in the JVM, this is the JVM now. You will have two places. One is called as the stack. The other one is called as heap. See, there are too many memories. What you will find in JVM. So many logical memories are there. Register, PC, so many are there. But in Java, when we talk now, we developers especially, we focus on only two memories. Okay, other people are there. They will bother about all the memories. PC, register, so many memories are there. Extern, so many registers are, so many locations are there. So who is bothered about those kind of memories? The people who invent JVM. Okay, supposing I want to invent on JVM and all that, then I'll bother about that. But if you want to use, this is more than sufficient. So developers should bother only stack and heap memory. So what is that happens now? Let's see. As soon as you say Java demo now, all the .class files, they get loaded into the stack. Okay, all the .class files, when they are loaded, they'll be loaded into the stack. Okay, but objects are getting created in the heap. There's a difference between stack and heap now. So all objects reside in heap, but all classes reside in stack frame we say. Okay, let's see this now. So this is our program now. Now I'll write a very simple program. I'll write class demo here. Hello H1 is same code I'm writing. Nothing, no difference. Hello H1 is equal to new hello. Hello H2 is equal to new hello. Okay, we declared variables now. First, h1 dot y is equal to 10, h2 dot y is equal to 20, h1 dot m1. Like this you can call the methods. Okay, so this is how the class gets. Which one first class is loaded? Demo class. This will be loaded into one stack like this. Okay, then hello class will be loaded now. Like this in the stack, frames will go on building because we are saying now. So demo goes on executing. Main method starts off execution. Okay, first demo dot class is loaded. After loading demo dot class, next it comes to this line. Main method starts off execution. Here nothing happens. Here nothing happens. Here hello class has to be loaded into the JVM. So hello class will be loaded now. This is class hello now. Let's see what happens in class hello. What are the members? You'll have x, y. Leave that. There will be only method here. Void m1. Int m is equal to 7. Box p is equal to new box of 1 second, we need space. Box b is equal to new box of 1 2 3 SOP x, SOP y, SOP m, SOP b dot w, b dot h. So the second class is, sorry, 1 second, I drew it wrong. Hello class, no? Yeah, correct. So hello class has been loaded into the JVM. So when it is got loaded into the JVM? When you created the object like this. h1 is equal to new hello. The time the object has to be created, first it will load the class and then the objects will be created. Now let's see what happens in the heap now. So as soon as the class is loaded, the static variables are declared and initialized first. What happens? The static variables are declared and initialized. So this will be x and the value of x is what now? 5. So first hello class got loaded. Leave demo now. We are talking about this line h1 is equal to new hello. This execution we are talking now. Okay. So hello h is equal to new, h1 is equal to new hello means first hello dot class gets loaded. Static variable is declared and initialized. So where is your static variable? It is present in the heap. If you want still more technical, the static variables are present in on memory space called as permgen. Permgen's memory space they tell, but don't bother about this. Just think static variables are present in heap. Permgen, P-E-R-M-G-E-N, permanent generation memory or something they say. Do not bother. But just you understand, you don't go deeper and tell in the interview. Interview, this is a definite interview question. Where are static variables stored? Static variables are stored in the heap. That answer is more than sufficient. But in depth if you ask where it is stored, permgen space or permanent generation space. In short they call it as permgen space. That's it. Okay, it is stored there. But we'll draw it in the heap itself. Let's not bother. I told you there are too many things in the memory. Let's not worry about that. It is stored here. Okay. So after the static variable is declared and initialized, see here one more thing happens now. So in this frame, h1 is a local variable. h1 is called as what? Local variable. So first h1 has been declared here. Here h2 has been declared and they have been initialized to null. I didn't draw this also. Fine. After they have been initialized to null, then h1 is equal to new hello. First these variables will come into existence. h1 they are null, h2 is null. Then after that h1 is equal to new hello. Class got loaded, x has come into existence. Then memory will be created, allocated for what? Y. Y is an instance variable now. So now memory is allocated for instance variable. Where it is allocated? In the heap. So both static variables and instance variables reside in the heap. Both. Okay. Both are residing in the heap only. But technically if you say static variable is present in permgen space. But don't bother. Both reside in the heap. Okay. So now see h1 dot y is equal to 10. That's what it's telling. Okay. Next we are telling h2 is equal to new hello. No? Fine. Next line is h2 is equal to new hello. Now what will happen? Class has already been loaded. Which one? Hello class has already been loaded. Only instance has to be created. So it will create the instance. So one more. So this is one h1 now. Earlier h1 was referring to null. But now H1 is referring to what? Object. Similarly, one more Y memory is allocated. H2 was referring to what? Null. Now H2 will refer to what? This object. It will be referring like this. So like this, as you create more objects, memory will be allocated for the instance variables, and these variables will start referring to this memory. But when I draw it in a different way. Okay, that is for your understanding purpose. Okay, this is the object, these are the members. For making you understand that, I'll draw it in that way. But technically in the memory, this is how it is happening. Okay, since I cannot draw complicated diagrams, I do not worry much because these diagrams we don't bother much. Why we don't bother much? End of the day we have to understand what is class, what is object. Okay, so anyway, actually internally in the memory this is what is happening. Fine. After this, and then we say after the two objects are created, this is the memory allocation. What we say 150, 250. We have to keep telling now memory allocation. This is the memory allocation. So in that X will be there. Sorry, this is one memory allocation. Are you finding it now? 1 second, I draw it still more clearly. The address is 150. This is 250. Here you got Y. Both are 0. Now what will I say? H1 dot Y is equal to 10. So H1 dot Y means it will change it here. H2 dot Y is equal to 20 means it will change it here. But one more fact is both H1 and H2 refer to what? The same X. So there is only one copy. Okay. So this is how the things are happening in the JVM now. Then next, I'll call method H1 dot M1 method. I'll call. So when you call H1 dot M1 method, now what happens? M1 method. This is the M1 method. So it starts off execution. So when M1 starts off, M is a local variable. M is a local variable, no? M is a local variable. So that is declared and initialized to 7. Next you are writing box B is equal to new box. B variable comes into existence. But where is the object created? In the heap. So check out now. All these are local variables. B is a local variable. M is a local variable. Similarly, H1 and H2 are local variables present in main method. They are all local variables. There are only 3 types of variables in Java: static, local and instance. Only 3 types of variables are there. So till now what you work, they are all local variables to main method. So now let's take this now. M is declared. B is equal to new box. Object is created where now? Here. So in this memory it can be 350 or something. What will happen now? W will be there, H will be there, D will be there, and values will be automatically initialized to 1, 2, 3. We are sending the values now. So object is created. B is referring to that. Now M1 is getting executed. See SOP X. So you are calling H1 dot M1 now. Okay. So H1 dot M1 means X, what it will do? It will pick the value from here. You are saying H1 dot M1. Okay. See, instance variables copy will depend on the number of instances you are creating. But methods, there will be only one copy. When I draw the diagram, how many methods I draw? In every object I draw one method now. Why do I draw that? To just make you understand members of the class. My intention is there to make you understand members of the class. Means when you create an object, what all members you can access. That is my intention. Okay, but technically if you see, there is only one copy of the method. This is how it is used optimum. This is optimum usage of the memory. Simply for every object, one method gets memory gets allocated is waste. Understood? And for any reference variable, let it be of box type or hello type, always 8 bytes of memory gets allocated. Always 8 bytes. So how much of memory got allocated in the stack here? Notice 4 bytes of memory for M, 8 bytes of memory for B. It's a reference variable. 4 bytes Y for M, it's int. B 8 bytes Y, it's a reference variable. Now in the heap, how many memory? 12 bytes. Why 12 bytes? 4 for W, 4 for H, 4 for D. Means totally 12 bytes. So 12 plus 8, 20 bytes of memory has got allocated for box. But 8 in stack, 12 in heap. Okay. So then SOPX, what it will do now? It will pick it from here. SOPY, it will pick it from here. This Y it will pick, not this Y, because you have called H1.M1. Then it will print B.W, B.H, B.D, everything will execute. After the execution is completed, method completes execution. As soon as the method completes execution, local variables are destroyed. Which variable is destroyed now? M is also destroyed, B is also destroyed. As soon as B is destroyed, what does this object become now? Dereferenced. Still these are all referenced only, noticed. So the JVM will mark this as dereferenced object. It will mark, somehow it will put a mark. Okay, as soon as it is abandoned, it is dereferenced, immediately the JVM put a mark on it. Till now we were dereferencing it deliberately. H1 is equal to null, H2 is equal to null. All that will not happen. Okay, if you are interested, you do it. But technically in the JVM, this is how it will go on getting dereferenced. Many times, automatically the objects will get dereferenced. I was just making you understand the meaning of dereferenced object there. But this is how it will go on happening. So this method completes execution now. This object will be marked as dereferenced. Next, one more method you will call h2.m1. Again, what happens? Again, m1 starts off execution. Again, what happens? Again, one more m will be declared. It will be initialized to 7. Again, one more b will be declared. Object will be created. So where is object getting created again? WHND 1, 2, 3. And what is the value? 450. That address is given to b. Same thing. And again the method goes on executing. But this time the value of x will be what? 5 only. But y will be 20. Because you have called h2 dot. Understood? You have called h2 dot. It will pick the correct value. If it is h2, it will pick it from h2 only. When you are calling the method, depending on the object, it will pick the value. Only one method, but it can pick the value. If it is h1, it will pick the value of 10 from y. Okay, if it is h2, it will pick the value of 20 from y. Like this it will be working and it will process. Again, as soon as the method completes execution, these two variables are destroyed. As soon as they are destroyed, automatically what happens? This gets dereferenced. So like this, JVM will keep on marking all the dereferenced objects. So even for hello also you can see here, when you say hello h1 is equal to new hello, how many bytes got allocated? 8 bytes of memory. Here also 8 bytes. Then h1 is equal to new hello, how many bytes got allocated now? 4 bytes in heap for what? Y, and 4 bytes in heap again for x. But h2 is equal to new y, only 4 bytes for y, like this. So totally you got 16 bytes here. Here 4 plus 4, 8 bytes. There are 16 bytes for h and here 8 bytes for y. Like this it goes on. Okay, so these are also local variables. And what happens when main method completes execution? Here, when main method completes execution, that time h1 and h2 will be destroyed. And that time even garbage collector will come and dereference that, collect those dereferenced objects also. So everywhere it is a local variable. If you are seeing, most of the places it will become local variable only. So this is how it will be going on executing. Are you clear? So static variables, where do they reside? Heap. Instance variables also reside in heap. Local variables reside where? Stack. Understood? So local variables always reside in the stack. And when do the static variables come into existence? When do the static variables come into existence? When the class is loaded. When are they destroyed? When the JVM shuts down. Till the JVM is running, you can go on using it whenever you want, wherever you want. Understood? It is already there. So then when do the instance variables come to life? When the instance is created. When are they destroyed? When they get dereferenced. Understood? When do the local variables come to life? When the method is invoked. When are they getting destroyed? When the method completes execution. So you should know when they are alive, in scope, when you can use. Okay, when you can use all that, you should know very clearly. Are you clear with all this? So this is how the memory goes on functioning in the JVM. Do not bother too much about this. Here I am just giving you an idea, the life and scope of variables. How long they are alive, from where and all you can use. That is the main theme. Do not go too much into memory, because we are not going to invent JVM. We are just going to use it for programming. So from the usage point of view, understood how the JVM has to be used. Okay. Do you have any questions here? So the classes are always loaded into the stack frame. Getting it now? Objects and instance means instance variables. They are created in the heap. Static variables also reside in the heap now. Clear? So this much brief idea about memory is sufficient for you. How much of memory is getting allocated? You generally had a question. How much of memory gets allocated? How much of memory gets allocated? For any reference variable, it is 8 bytes. Primitive variables, you know the value. Now it depends where it will be allocated. Okay. See, we have seen primitive as instance also. We have seen primitive as local also. So if m is a primitive variable, 4 bytes is allocated in stack. But if the same w is an instance variable, 4 bytes is allocated in heap. It goes on shifting like that. Stack, heap, stack, heap. That's it. Depends on the type of variable. Your variable is of type what? Okay. Reference variables always 8 bytes. It is default. Let it be a reference variable of anything. See, reference variables contain only reference value. Understand that. Test T, box B, hello H, they all contain what? Reference values. It's standard now. For any reference variable, even for array reference variable, array, Okay, for that also 8 bytes of memory is allocated because they hold the reference value. Understood? So that is the type of memory allocated, but where it is allocated depends on the type of variable. Clear? So stack is purely for local, and instance and static is for heap, are present in the heap. So this is how the things have been organized. Do you have any questions here? I'll clear the diagram.
When box B is called, on stack will be one more box. Class box.
Yeah, one more class box. Yes, one more. His question is, when box B is equal to new box, when we say one more class box will come into a stack frame now. It goes on. How many classes are loaded into the JVM? Class box will again be loaded into the stack frame here only. Somewhere in the stack frame it will be loaded. Okay, again class box is using some other class. Again it will be loaded. Goes on. So classes are loaded into stack frame. Objects are created in the heap. It goes on. Understood? It's a big cycle. So like this, see, what we code in source file is different. When we compile, dot classes are generated. But later on, these dot classes are loaded into the JVM. Objects are created and then they are processed. This is how the cycle is of Java. It's very simple concept. Okay. So see, till now we are studying still the same topic. What? Class and object. More than that we didn't go ahead. And that's all is there in Java. There's nothing more also. What is a class? What is an object? That's the only topic here. But it is a huge subject. Definition wise we have learnt. What is an object? Definition wise we have learnt. What is a class? Definition wise we have learnt. But how it gets processed, that's what we are learning now. Clear this? Any other questions? Clear? Only one copy of static variable, clear? Okay, I'll give you some more programs about main now. Now you'll start clearly understanding. You can have instance variables in the class containing main method also. I'll be showing you. Till now I was writing only what? Static members. You noticed now when I was writing class demo, I was writing main method. In that only I was writing M1. But carefully, if you have noticed, it was static M1, static M2. Today also if you want, I'll write instance members. Now you'll get the clear idea about how to write the class. 2-3 days, you're perfect now. Understood? You'll write very good classes now. So do you have any questions in this diagram? Shall I clear? You got the 3 type of variables? Shall I clear everything now? Do not bother about this memory too much. Just understand it is stack and heap. Developers are only considered about stack and heap. In fact, in books when you read, they'll tell heap and non-heap. They'll not even mention stack. Some authors will mention stack. Some authors will mention what? Heap and non-heap. Non-heap means stack. Understood? They talk like that. Heap and non-heap. So the first class is always loaded with Java command. Other classes are loaded with new and all that. And JVM will be keeping a track like this. So that one point I forgot to tell you. So what it feels now, see, even if I don't call the garbage collector, what will happen? When too many dereferenced objects are there in the heap, garbage collector will be sent by the JVM. JVM only will send it. JVM itself will send the garbage collector. Once the garbage collector comes, it will collect these 2 different dereferenced objects. But before collecting these 2 dereferenced objects, it will execute finalize method. If it is present, it will execute the finalize method and then it will collect it. Okay, supposingly it is connected to database. You have to release the resource. If it is not connected to database, fine, it will be cleared. If it is connected to database, it will not clear the resource. If it is object level resource, I mean to say. You know object level resources now? So if your object is initialized with some object level resources, the garbage collector refuses to collect that dereferenced object. And this is what we call it as waste memory. Okay, even though it is dereferenced, it will be lying in the JVM only. They will consume memory. It is waste. I tell you now, Bethard. Bethard means like on Bethard, it will be moving in the JVM now. So to clear this, what you have to do? You have to release the resource first. In Java, we do not bother about destroying the memory. We only bother about releasing the resource. You just write that code in finalize method, automatically that memory will be reclaimed back for some other object creation. So but these 2 objects it will not create. Why? They are referenced. So that is why whenever the object gets dereferenced, the JVM will put a mark onto it. As soon as the object gets dereferenced, some mark it will put, identification. So that when the garbage collector comes, it will collect away all the dereferenced objects. And it's a program. Garbage collector is nothing but what? One program which is executed by the JVM. When does the JVM execute the garbage collector? when it finds too many objects are there in the heap. Whether you call or you don't call, if I want I can call it system.gc. If you don't call also, still it will be sent by the JVM itself. Okay, more about memory management, which one? Garbage collector and all, that I will tell you later. Here I just introduced what is stack and heap. Still more one big detailed topic is there about how objects are created and how they are collected by garbage collector. One more detailed class is there on that. Okay, so step by step I will go on introducing all the topics to you. So shall I clear all this now? So some notes is there, you can just make a note of all this, very important points. The summary of all this. There are three types of variables: static, instance, local. Static variables. I think we have discussed much about static variables last class. Same topic, nothing new. See this. Variables which are declared as static are called as static variables. Static variables belong to class and they do not belong to instance or object. Memory will be allocated for static variables, or when they come to life, when class is loaded into the memory, when they come into life. Static variables are destroyed only when the JVM shuts down. They have a very long life. Static variables are declared and initialized to default values if you do not provide values when classes are loaded into JVM. They have default values. There is only one copy of static variable and it belongs to class, we say. Okay, static variables behave globally. Why? If you change the value, it will affect everybody who is accessing the value. Okay, then static variables are not global because they have to be accessed with class name or reference variable name. Means Java does not have the concept of global, but static variables behave globally. Understand? Okay. Then static variables can be accessed in static context, methods or blocks directly. Static variables can be accessed in instance methods and blocks also, both the locations. This example I gave you in the last class. Okay. Then static variables are stored in the heap. That point we have discussed today. Scope of the static variable, that is static variables can be accessed inside the class directly or outside the class with the help of dot operator. Operator should be used with class name or reference variable. Operator should be used with class name or reference. Dot operator should be used with. If you want to access it outside the class, you have to use dot operator. Okay, static variables are used when same value is needed for all the instances. That is optimum memory usage. Instance variables are declared and initialized. Second topic now, instance variables. Instance variables are declared and initialized, or they come to life when the object gets created. They are destroyed when the object is dereferenced. Instance variables are declared and initialized to default values if we do not provide values. If we do not provide values, they'll get the default values in every object when it gets created. See, instance variables belong to objects. Number of instance variables will depend on the number of instances created. If any instance variable is modified in one instance, it will not affect in other instance or object. If you modify it in one location, it will not affect other place. Instance variables cannot be accessed in static context directly. You cannot access it directly. Instance variables can be accessed in instance methods and blocks directly. Directly you can access it. Instance variables reside in heap. Now last one. Okay, sorry. The scope. Scope of instance variables. That is, instance variables can be accessed inside class or outside the class. Inside the class directly you can access. Outside the class you have to access it with dot operator, and dot operator should be used with reference variable. Okay. Instance variables are used when different values are needed for all the instances. Now last one, local variables. They are declared and initialized when the method is invoked. They are declared and initialized when the method is invoked. They are destroyed when the method completes execution. We should initialize local variables before using, otherwise we get the variable might not have initialized, compilation error. So only local variables have to be initialized. You don't have to initialize what? Instance variables and static variables. Only you have to initialize local variables. Okay, before you use. Okay, see class box. I'll not initialize int w. I'll not initialize. But as soon as the object is created, w will get default value. Supposing I write static int h. I try to use it. Fine, no problem. I'll get the default value of 0. Box b is equal to new box b dot w is 0 now. Box dot h is 0 now. So I don't have to initialize instance variables and local variables. Sorry, instance and static variables. But I'll declare one local variable int l, SOPL. I'll get the error now. Variable might not have been initialized. We have to only initialize always local variables. Now what is the value you give to the local variable? That depends. Either you give the default value or you give the required value. Int l, what value I'll give? It's the default value of int is what? 0. You give the default value. And you initialize it later wherever you want. L is equal to whatever you want, you initialize. Okay. Or like we calculate the volume. Int v is equal to 0, w into h into d, I'll give it to v. This is one way of initializing. Or you hard code it here itself. That is your wish. So this is how the local variables will be initialized. Either you hard code it here or you give the default value and later on initialize it. Are you clear? But before initializing, if you try to use SOP, you try to use it. Not only print, try to use it. Not only printing. See SOPV, or I'll declare one more variable int y. Y is equal to v. I'm trying to give the value of v to y. Use it. You'll get the error. What error? Variable might not have been initialized. So be careful with local variables. Be careful with local variables. You'll always get this error when you don't initialize and try to use it. When you try to use it, you'll get the error. Supposing I'll declare it, I'll not use only, I'll not get any error. I'll not get error. You try to use it without initialization, what is the error you'll get? Variable might not have been initialized. Compilation error you'll get. So be careful with this compilation error. Yeah? So they are declared and initialized when the method is invoked. Local variables, they are destroyed when the method completes the execution. We should initialize local variables before using, otherwise we get the variable might not have been initialized, compilation error. Local variables reside in stack. Scope of local variable, that is local variables can be accessed only within the method directly and not outside. You cannot access it. Static variables and instance variables can be accessed locally also, outside also, but local variables only inside the method. Are you clear? If you want that value outside, argument, return type, this will go now. It depends. If you want to give the value to caller method, argument. You want to give the value to callee method, return type. Value in the method, you can give it to two methods. One to caller method you can give, or to callee method. Caller method means argument. Callee method means return type. That's how you can give the value, but variable cannot be accessed. Now local variables are used when new value is needed for every new method processing. That's up to you how to use it. Are you clear with all this now? One final note. What is a note? Static and instance variables reside in heap and local variables reside in stack. So almost all we are coming to the conclusions. So many doubts were there. Okay, all of them will be cleared now. Step by step they will be cleared. Okay, just 2-3 more days, all your doubts will be cleared now. Clear? Okay, now this is about the variables. Now we'll be discussing one more next topic, which is a very important topic. That is class loading and object creation. There are two phases. See, there are two phases which happen before an object gets created. Which are they? Class loading phase and object creation phase. We'll see this now. Sorry. There are two phases which happen before an object gets created. What is the first phase? Class loading phase. Second phase is what? Object creation phase. I'll take the first one. I'll explain you this. Then I'll explain you object creation phase. Okay, class loading phase. So now, class is loaded into the JVM under what conditions? Till now what you asked. Still more ways are there to load a class into JVM. That's why I'm not completing what are the different ways to load a class into the JVM. I'm only telling you what happens when a class loaded into the JVM. Till now we have seen there are three ways. One is Java command, new, when you access a static member. Okay. Okay. So how to load class into JVM we'll discuss next. But what happens when a class is loaded into JVM, that we'll discuss. Clear? See, when you load a class into JVM, I told you can load it in three ways. One is loading a class into JVM, Java command. But Java command is used for loading only class which contains main method. Other classes are loaded with new. Then you can, if you access a static member, access a static member also, it is loaded. Fine. You can access a static member. It can be a variable or it can be a method. That is different now. It will load. So after loading, let's see what happens. See, when a class box is loaded into the JVM, just I am telling you an example now. First, the stack gets loaded into the stack frame. Assume that this is stack only. It will get loaded. Volume method will be there. Return type is int. This will be loaded. Okay. So as soon as this one, the stack is loaded. This is stack memory now. Okay. Internally what happens is, one more thing what you have to understand is, okay, an object of, there's a class, there's a built-in class with the name called as class. Class. It is an implicit class, means built-in class which comes from the library. We'll be discussing about library classes later, but just I'm telling you the process. As soon as a new class gets loaded into the JVM, an object of this class gets created implicitly. Implicitly it will be created. Implicitly, understood? So, and this class object will be there in the heap only now. You know this is heap. So this is an object of what? This is an object of class. Look at the spelling how I am writing. Object of class. One C is keyword, other C is caps, class. So this gets created and have complete information about the loaded class. It have complete information. How many variables are there here? How many methods are there? What is the signature of this method? What is the return type of this method? Okay, complete information about the loaded class it will be having. How many constructors are there? Okay, that complete. So object of class contains what? Contains complete info about the loaded class, the newly loaded class. And this will be created implicitly. I will not create it. You will also not create it. I will not create it. You will not create it. I will not say class C is equal to new class. Automatically the object of that class is created. Okay, it will be having that complete information. Supposingly I tell hello H is equal to new hello no. Okay, so that time one more class is loaded into the JVM now. So that time hello class will be here in the stack. This is class hello. It can have some variables, int x, int y. It can have m1 method. All this is secondary now. What members it contains is secondary. So as soon as one more class is getting loaded into JVM, one more object of class gets created. So how many objects of class will be created now? Depends on the number of classes getting loaded into the JVM. So how many classes get new classes? Okay, and this object will be created only once. Why? Classes are loaded only once. So after loading class box and hello class into JVM, you can create 1000 objects of which class? Box class and hello class. Okay, but how many objects of class are there? Only one. One for hello class, one for box class. So this contains complete newly loaded class. Which one? Class box. This class object will contain about information about this. This object of class contains info about what? Newly loaded hello class. Understood? So whenever a new class is loaded into JVM, just understand that an object of class gets created implicitly. Implicitly means we will do it, JVM. Okay, and there's two extensively we'll be seeing this. This process in JVM there's a process called as reflection. I don't know how many of you heard it. Okay, reflection means it's the process of getting information about the classes during runtime. You will need the information. about the classes at runtime, means what are the members of class box. Physically seeing it in source code is different. Programmatically acquiring the values during runtime is different. Understood? I want W, H, D during runtime. So all these members you can access during runtime. We'll see how it is going to happen later. Okay, so class object helps you in reflection. Class objects helps you in the process of reflection, and developers will be using this object for reflection process. So I'm not teaching you reflection process right now. We'll see all this later. Do not worry, because when I start teaching you libraries, I'll be talking about all this process. It's a very simple process. Okay, but you have to understand now, when a class is getting loaded into JVM, okay, some steps will take place. Class gets loaded into the stack frame, first thing. Second thing, an object of class gets created. Then static variables are declared and initialized. Then static block gets executed. That's all you understand. One extra point I added. Do not bother about this second point which I told you now. Understood? So that is what you will be seeing it later. But the other 3 points you have to understand. Class is loaded into stack frame. Second point is object of class getting created, leave it. Third point is what? Static variables are declared and initialized. Static block gets executed. Correct. This happens when the class is loaded into the JVM. When the object gets created, let's see what happens. So these are the 2 phases. You should be clear now. When the instance is getting created, what happens? Reference variable is declared. Then instance variables are declared and initialized. Then instance block gets executed. Then constructor gets executed. Then address of the object is given to the reference variable. As simple as this. So these 2 phases you should know. Again, we are going to build too much on this topic later. So class is a built-in class. It has some members. See how I write object of class. Remember that. Write it carefully. Otherwise you will get confused. See, these are the points what we are discussing now. There are 2 phases which happen before an object gets created. One is the class loading phase. Second one is the object creation phase. So let's see what happens during the class loading phase now. Class loading phase. Following things happen during class loading phase. Class is loaded into the stack frame, that is JVM, by using class path variable. Next, an object of class gets created implicitly, which has complete information about the loaded class. That's all. This point you don't go much deeper. This second point. Now note, the number of class objects depends on the number of classes getting loaded into the JVM. Class is used by the developer for reflection process. We'll see this point in detail later. We need minimum require 2 to 3 hours to discuss this topic. Understood? Which will be held taken later. Okay. Then next, only the point, second point, it will take around 2 to 3 hours, which we'll see later. Then next, static variables are declared and initialized, or static variables come to life. Then static block gets executed. So this will happen during class loading time. There are any questions here? 3 points you focus: first, second, third. Yeah? Okay. Now what happens when you object creation phase? Reference variable is first declared. Correct now? You write now hello h1 is equal to null, something like that. So reference variable is first declared. Then instance variables are declared and initialized. Where? In the heap. Then instance block gets executed. Then constructor is invoked. Then reference of the object is given to the reference variable. As simple as that. Note, classes are loaded only once into the JVM, but any number of objects can be created after that. Remember that. Okay, so class loading phase happens only once, but object creation phase can happen multiple times for a particular class. It can happen multiple times. To create object, the definition of the class is required now. So we write classes, we compile it, then we load it, then we create objects. This is a complete process now. Are you clear? Okay, so class is a user-defined data type. It's a template. It's a logical construct. You know all the definitions for a class. You want any more definitions? That is more than sufficient. And finally, objects will be created for you. Clear? Are you clear with all this? Now we'll see some more examples on static. Some more examples I'll give you. You understood all the concepts. Some more tricky SCJP examples. SCJP examples we'll see now. Are you clear with all this point now? This complete static concept, and to make you the concept of static still very clear, I have to give you what? More examples. Nothing else. Clear? Clear? Are you clear this? Okay, now I'll give one question to you. Let me see how will you solve this. Class hello is there. Static int x is equal to 5. I am declaring and initializing it. Then I'll take one int y is equal to 9. I am hard coding it. That's not the issue here. My question to you now, right now, is I am having void m1 method. In m1 method, I can access both now. Blindly I can access now. Huh? Why we can't access? The answer is correct. You can't access y in m1 method because the method is static. Okay. You can't access here. Which one? Y. You cannot access. Okay. But in m2 method, I can access both now. You know the reason now? Instance members can access static plus instance members. Why means it's a question of coming into existence now. Here I can access because by the time m2 is executed, what has happened? Class also has loaded, static variables are declared already, and instance variables also have come into. That's why I can access both here. But in this phase I can't access y because instance members are not come into existence. All that you know very clearly now. Fine. But my question to you now is a very simple question. I want to access y here. How will I access it? You tell me. I can access it. Create the object of hello class and then access it. This is possible. So you know how to work now. Are you clear now? So these are some of the tricky things. You can't access it directly, but yes, this is a valid question. And see, valid answer. Hello h is equal to new hello. I'll create the object of hello. So when I create the object of hello, see, we are creating the object of hello class inside the same class. Notice, sir. Hello class object where I am creating. Till now we are creating objects of one class in another class. But sometimes you will create an object of same class in same class. Why will you do that? To access instance members in static context. Understood? Till now we are accessing the instance members in the same class. Till now we are accessing the instance members in the same class directly. Okay, that time we didn't have to create an object because we are accessing it in instance members. But right now the problem is I want to access the instance members in static context. So these scenarios might come to you. This is one of the examples. Here you might ask, what is the use? Here I can't show use. In practical examples we'll start seeing it. So if at all you want to access instance members in static context, it is possible. Not directly, but by creating objects. Directly it is not possible. I'm putting a wrong mark, see there. But after creating the object, yes, this is a valid output. This is 100% correct. These are tricky SCJP questions. They'll twist it in many ways. Okay, now see this. If you want the client program for this class demo, PSVM, see what will happen now. I will call hello.m1 method valid. So when you are saying hello.m1, you are accessing a static member. What happens? Hello.class is loaded into the JVM. X is declared and initialized. Understood? Then m1 will be called. What is m1 doing? Creating an object of hello class. Now y will come into existence. Earlier y did not come into existence. Only x had come into existence. Understood? Now y will come into existence and y can be accessed. Okay. If you want, you can make it still more interesting. What you do is, you write one static block here. Simply SOP inside static block. See the output. And here you put SOP inside M1 method. So before M1 method, what you'll see? Before M1 you'll see static block and then M1 you will see. Are you clear? So when will you create an object of a class within the same class? Are you following? When will you create get the question correctly. When will you create an object of the class within the same class? Okay, when static members want to access instance members. Simple as that. Good example now. Okay, so after understanding the subject so detailedly, you can understand this subject. So that's why I told you static is a big concept, and we'll write many examples now. Automatically start understanding. All your doubts will become clear now. Clear this? Okay. Then more examples we'll see. Shall I clear this example? Shall I clear? Now one more very interesting example we'll see. So now we'll try to add members into the class which contains the main method. We'll try to add members into the class which contains the main method. What all members? All members will add. Static members, static variable, static block, static methods, everything will add. Let's see now. See, this is class, demo class. Static int a is equal to 5. Static int b. This is static block. Observe the class carefully. So your class is having how many members now? Check. It's having two static variables. Correct? A and B. A has been declared and initialized. B has not been declared and initialized. So whenever anybody asks you the output, look into the class properly. Otherwise you can't predict the output. Don't rush to main method. First look at the members. Okay. So see, A and B are two static variables of type int. There is a static block. There are two methods now. Two methods are there. One method name is M1, another method name is main. Okay. Then M1 is having a parameter of type int. Return type of M1 is void and it is static. This is static. Same thing, static is the main is static. We'll see now. We'll discuss why main has been declared as static in a moment. Just wait. Okay, but this is also a method, static method, return type is void and it is main. So these are the members. So totally how many members are there? 2, 3, 4, 5. Two variables, two methods, one block. Correct? Two variables A and B, two methods M1 and main, and one static block. Look at the members. Now you compile. You know how to compile. Now I'll execute the program. And I say Java demo. Can you predict what is the output now? Okay, see, it's very simple. As soon as I say Java, JVM starts. When the JVM starts, it will load demo.class into the JVM. Understood? Demo.class will be loaded. How it will be loaded? Class path variable will be used. It will load it into the JVM. Once it is loaded into the JVM, what happens? First, A is declared and initialized. Then B is declared and initialized. A is declared and initialized to 5. B is declared and initialized to 0. First static variables come into existence. Only thing is, till now our class containing main method did not have members. If required, you write there also. But generally we do not write members in class containing main method. Generally. Okay, we write all the members what? Inside other classes. That is process of encapsulation. Okay, if you write all the code inside class demo now, tomorrow for reusing it will be complicated. So that's why what we do, we write all the code in other classes. But this is a valid code. This is highly valid code. Your class containing main also can contain other members. So A is there, B is there. So first they are declared and initialized. A is declared and initialized to 5. B is initialized to 0. Now static block gets executed. So before you see inside main, the output what you will be seeing is what? Inside static block. And now B's value will be overwritten. Earlier it was 0. It will be overwritten to 15. I'm just making you understand. I could have given a value for B here also. But I'm just making you understand the concept. A was declared and initialized. B was also declared and initialized. But now the value is overwritten. Where in the static block. Then main method starts off execution. So after the class is, any class is loaded, same process will happen. No difference. Static variables are declared and initialized. Static block gets executed. Same process. But in this class, since it is the first class you are loading into the JVM, JVM will look for main method. And now main method will call which method? M1. Now M1 you have to call. If you don't call, it will not execute. But for calling M1, what you have to send? Argument. Because it's having a parameter of type int. Now M1 will execute. It will print A, B, X, 50, whatever it prints. Are you getting the flow now? So if you want the previous program and this program, I will type and show you. Understood? The previous program is what? Accessing instance in static block. That also I will type and show. This also I will type and show. Clear? I'm sure writing 2 examples. Are you clear with this? Okay. Then say the thing is Java demo. So then more we'll see. Then say supposingly I remove static here. For M1 I will not make static now. Now things are interesting. Can A and B accessed in M1 method? Can A and B accessed in M1 method? Yes. Static members can be accessed in instance members. This is valid code. You can have an instance method in class containing main method. Understood? But this method cannot be accessed here. That is the problem. So how will you access now? Now it becomes important. What you have to do? To access instance members in static context, what you have to do? This will not work now. So I have to say hello h is equal to new hello and then call h dot m1 of that method. Getting it now? Perfectly it will execute. This was the same example I gave before. Now we are seeing little practical application of that. Understand the previous example first, then automatically you understand this. If at all you want to access instance member in static context, you have to create an object and access it. Correct? You are creating the object of same class inside same class. Demo class object you are creating, now what happens when you create the object? M1 comes into existence. Now I can access it. So that is why even I was clear. I was not clear. I was clear also. I was clever also. Initially, when I gave you so many examples on Java, what did I do? All my methods I was making it as static. Why you know? I didn't want to create an object and access deliberately. Why? That time if I remove static and then if I write this kind of coding, you will ask me, what is that, sir? Obviously I can't justify it. To justify that, you require so many classes. Understood? No? So a class containing main method can have other members and you can access other members in main method. No problem with that. Understood? But how you access other members in main, you notice, because main is static. Static members can be accessed directly. Instance members, you have to create an object only and access. Understood? But generally we do not write other members inside the class containing main method. But in colleges they teach you like this only. Can't help. Why? You know they are very intelligent, you are also very intelligent. Because learning a class is no joke. We have put nearly around 15 days of effort and then we are understanding what a class is. After those many classes you are understanding what now? What are static members, what are instance members, how to use them, how to create object. So this much of explanation is required. Okay, and in colleges it doesn't mean that they can't teach, they can teach. But you are not interested in sitting for classes. That is your problem. Understood? So anyway, there you are not learned. At least put effort here and start learning properly. Are you clear with all this? So I am repeating again. A class containing main method can have other members. The other members can be static or instance. Same. You can have, what are the members? You can have a constructor here also. You can have it. That's your wish. But generally we do not write such kind of coding in main, because in the class containing main, because if you write all the code in the class containing main method, what will happen now? It will become very difficult to maintain and manage. So that's why we write it logically, like some code in one class, another code in another class, another code in another class. If you split the code like that, tomorrow for you only to use, it will be very easy. Which code you want to use, you can create an object of that class, and then you can start working with that complexity. So that is the better way of writing a class as compared to this. But this I taught you, reason is many examples you'll be seeing things like this. Okay, generally most of the books you'll be seeing programs like this only. They'll never be teaching you how to write a class. Even if they teach, they'll teach you only in one line or two line. Okay, so that's why clearly I'm giving an idea how to write classes now. Are you clear with this? Okay, then one more small change here itself. Same program, you can notice. I want to print, see this is one more very important interview question. I want to print hello world. These are all interview questions now. I want to print hello world without using main method in Java. Is it possible? Is it possible to print hello world without main method? 100% possible. I'll just write on static block, nothing else. So see this, class demo, just I'll write on static block. SOP hello world. What happens? Java demo, compile it. Class is loaded. Static block gets executed now. It will execute, and in this class it will look for which method? Main method. It will search. It will not find. You will get the error also. What you will get? No such method found error you will get. I am not saying no, but definitely it will execute. Static block gets it will print hello world. Error will come. Which error? Not, see there are two errors you should know. No class definition found error. This will occur when the class is not there in the class path. Okay. One more is no such method found error. Means class will be found, but in that class main method is not found. You get this error. You will not get this error, but you will definitely get this error, because main method is not present in your class. These are all very tricky questions which they will ask you in interview. Are you clear with this? Okay. So this is one output. Now you might think, see now there is one mechanism to start execution in Java without main. You can start the execution in Java without main also. How? By using static block. But we don't take this approach. Why you know? If you take this approach, can I send command line arguments? But with the help of main I can send what? Command line arguments. So static block does not support command line arguments. So always main method supports command line arguments. So even though there is a possibility to start the execution without the help of main, even though there is a possibility, we always depend on main method itself, because tomorrow you need dynamic values into your program, you will have problems. So that is why always we will write main only, and execution will start from main itself. Understood? So a class containing main method can have other members, no doubt about it, but execution starts from main only. Remember this. You can have hundreds of methods in main this class. See the first class, remember this point always. When you say Java demo, Java command should be used for loading the class which contains the main method. Remember that. Understood? Java command should be used for loading a class which contains the main method. Remember that. Okay. Now that class can have other methods, other members, other blocks, whatever it wants it can have. But JVM will look for only main method. That too small m only. Are you clear with this? So in this, see these three examples now which I discussed. Accessing instance members in static context. First we'll see that, then we'll see this program, then we'll see this. Then there are more examples. So as you go on coding, you'll get better idea now. I'm telling you, within 2-3 days, the idea of writing a class will become perfect for you. Understood? So writing a class is no joke, which are neglected throughout your life. So that is why I am facing so much of difficulty to make you understand what is a class and object. Because you are already sitting here telling what? I know what an object is, I know what a class is. To make you convince that you don't know and then teach you is a mountain task for me. Understood? If I tell you don't know what is a class and object, you'll never believe. Definitely you'll tell what? In my 4 years of engineering, I learned that only. What you are telling now? Understood? So obviously, you can see no. Are you clear with this? Shall I clear? Do you have any questions in this example? Anything you want to manipulate? This here, that here, while coding only you can ask, I'll show it to you. Access instance in static demo. Clear? Huh? First I show it in other classes. Int x, what is the code I wrote? Is equal to 5. Int y is equal to, okay, I didn't give any value of hard coded, no? We hard coded this. Is equal to 9. But in this x was static. Fine. Then we had one method. I'll write M1 later, but first I'll write M2. In M2, it is instance. In M2, inside instance M2, inside instance M2, we will print the values here. Inside instance M2, sorry the spelling, inside instance M2 plus y plus x. See, this will not be a problem. We can execute this code. It's not a problem for us. I'll try calling M2 method now. So in the instance context, you can access what? Both. So now let's compile. The program compiles. There's no errar here. Okay, after compiling, we can execute. Only hello world will print because you are not using that hello class. Now if you want, you can use the hello class. Or I'll take null first. Okay, and I'll call h.m2. Fine, perfectly works. Correct? Huh? We know how to access static members in instance area. It is happening. But the same code, we'll do it here now. In M1. Inside static M1. I'll not write any code here. I'll just comment off all this too. First you can check the error is there itself. Where? In M1. If you're not even using it, it will not compile. Non-static variable y cannot be referenced from static context. You'll get this error. Because how can you access y in static context? Not possible. So what I have to do now? I'll comment this. Okay, it is not possible, no? Okay. But we'll do it. See this. How we'll do? I'll say hello h is equal to new hello. I'm creating an object there. And then I'll print h dot y. Once again, I'll let this remain. In that way, directly it is not possible, but I can access it with what? H dot y. This is possible. So now what I'll do, I'll declare the variable. After declaring the variable, see, for calling M2 I have to create object, but for calling M1 I don't have to create any object. But in M1 I'll create object. Getting it now? So this is highly correct now. Code H is equal to new hello. Sorry, I put 0 here. Okay, now it will work. So to access instance members in static context, we create objects. Means we create object means, see, it's very simple. Only when they are existing you can access. Do not get confused here. Bring them into existence and access. When they are alive you can talk with somebody, no? When nobody is alive, how you talk with them? Understood? So first bring them into existence and then work with them. Simply without bringing them into existence, I'll work means what will you work? Understood? So first bring them into existence. How you bring them into existence? Notice. Depends on the type of code where you are writing. Where you are writing code, how you are accessing, that depends. So are you clear with this example? Not only method. See, I'll remove this and make it into a block. In static block also I can create what? Object. Static context I mean. When I say static context, it's understood. Either a block or method. Now it is, see this. I cannot access it directly. Is it possible? This will again give me an error. It will give me compilation error. Non-static variable y cannot be referenced. Understood? And here one error is there. We are trying to call M1 which is not there. I'll remove that. Now let's see the error. Y cannot be referenced in this. So what should I do now? Yes, you can do it, but just by creating an object. Okay, then, but how do you call the, means how do you notice it now? Okay, you make this one as, okay, I'll just access h dot x I'll access. Now you see what all happens. I'll just print plus, which one is static? H dot x. So now see, static block is loaded. Static block is, say I'm writing method here, it is block. But in block also I can create object now, anywhere. But the concept is very simple, man. If you want to access instance members in static context, you have to create object and access. Understood? Fine. Do you have any questions here? Okay. So we'll see the next example now. Different members in main class. Understood? We'll see different members in main class. Any other R&D you want to do here? Do it, you'll come to know. You don't have to worry, all your doubts will be clarified, man. Simply if you tell me, there's no use. You only practice it. You only get all the idea now. You know how to write good classes. Okay. Different members in demo class. Correct? Huh? Different members in demo class. Yes. See what all I want, I'll have now. You want, first I'll go with all static members, then we'll change it to instance is equal to 5. If you want, I'll write on static block also. Okay, B I'll initialize here. You can initialize with any value. It's not that you have to multiply with this one with 1 or 2 or something like that. Any value you want, you initialize. So it will be initialized here. Then I can write on static method. First I'll show you all static members here. Then we'll go with instance members. Static void m1 int x. Inside static m1 method. Then you can print. What values you can print? A is plus A. Value of B is plus B. I'm just printing the value of local variable also, that's up to you. Just I'm showing you how to send argument there. This is where statement, remove it. Okay, this is done. So now hello world. See, when I run this program, what happens, notice, even though there are so many things there, only hello world will print. Hello world with what will print? Static block. But these two are declared and initialized. We can't see it. If you want proof, you print it here. Okay, I'll print it 2 times here. Inside static block plus A plus B I will print. So again you can print these 2 statements after initializing. Check out. It will clearly tell you that A and B have come into existence here only. They have come into existence and then B value is getting overwritten here. So first those 5 statements will print and then main will execute. Notice. But JVM is good enough to execute that block and then main method also is called. Notice. But main method is getting static block is getting executed first. So inside static block, A has been declared and initialized already. That's why it's printing what? 5. Why it's printing all this? When the class got loaded, what happens? Static variable are declared and initialized. Then static block gets executed. So A is 5, B is 0. Then A is 5, B is 10. Then main will execute for what? World. Hello world. Are you seeing the flow? Okay, then next. Invoking the method. How will I invoke the method? M1 and I'll send a value 55. You can send any value. I'm not telling send 55, but you have to send an argument of type int. Now see, M1 also will execute. So main method will call other methods. Those other methods might be present in same class or in other classes. If the members are there in other class, you know how to access now. What will you do? Box B is equal to new box. Then you will start working with objects. You will create objects of that. You will have a reference variable. With the reference variable, you will start working with the object. That's how the flow will continue now. Are you clear with coding now? Okay. So then by chance, I'll remove this static and make to instance. Okay. This if I comment it, see it will not compile now because I am accessing instance member M1 in main. I can't access M1 in main because it is instance, but otherwise it will compile. It will execute the static block. But M1 I can't access. So if I want to access M1, now the story will start again. What? Okay, it's a big name. I'll copy and paste it. What do you have to do? This class C is equal to new. Create an object of your class. Yes or no? Whatever the name of your class. Different members in class demo. D. You can give any name, that's your wish. Then you call what? D dot M1. This is valid. 55. M1 also is getting execute. Okay. So then, if I want, can I execute the code in your class? Till you have any questions? You can make even here. Not only M1 instance, I can make B also as instance. Now you should know how to use it. If I want to access B in static context, not possible. If I want to access B in M1 method, yes, possible because it's instance member. But by chance, if it is static, not possible. Again, you should know how to work now. Are you clear with this? Yes. So now static members cannot access instance members. You are aware of that now? If at all you want to access instance members in static context, what you have to do? Create object like this and access. Yes. Now it becomes very clear. We had a question earlier, somebody, why can't I use this keyword here? You cannot use this keyword in the static context. Understood? This keyword is used for accessing instance members, not static members. You are adding the question. Somebody has asked the question earlier. Are you getting the answer now? You can't use this keyword because this refers to the current object. So when main method is getting executed, is there any object getting created of the same class? When main starts execution, see, completely understand here. If I don't create the object of main here, see, till now what is happening? Just understand the code here. I am having M1 method. Everything is static now. See, all the members are static. I am running the code now. Is an object of your class getting created? Sorry, I'll make this also static. Is an object of your class getting created? Which class? Till now, we have never created an object of our class which contains the main method. Till now. Understood? Till now, an object of our class which was containing the main method was never created. We had created objects of other class. So I was focusing on how to build other class. I was not focusing on how to write a class which contains the main method. Today I am focusing on how to write a class which contains the main method. But it is useless. Discussing about class containing main method is useless. Why? Because it contains only one member. But for you to make understand what a class is, I am showing you all these programs. See here, the object is not created, but still all the members have come into existence and the code has got executed because all are static members. Now in this scenario, if I use, supposingly I might have an instance member here. Example I'll write now, int b. You can write, it's not a problem, it will compile. See there? Sorry, int c I'll declare. You can declare it. It will compile, that's not a problem. It will execute also, it's not a problem. But we are not using C. If you want to use C, which is an instance member, now stories are different. Understood? If you want to use C now stories are different. You should know how to use C now. Now you have to create an object. Okay. Now after creating an object, now you can use this keyword. See this. Demo D is equal to new that object you create. After creating the object, what will you do? D dot, what will I say? I can say C is equal to, I can access it, D dot C is equal to 2, I can give a value, or 3, I can give any value, or I can also say this dot C is equal to 5. This is also valid. All this will become confusing. Okay, all this will become confusing, you try all this later. Do not bother about all these things right now. Okay, using this, just avoid it, you'll get confused. Only in class containing main method. Other classes you are comfortable using what? This keyword. Only here you'll get confused. Okay, so just you can practice these things later. I just told you why you can't use this keyword in main. Because it's a static context and you are trying to access instance member. And to access instance member in static context, there are some rules. Okay, there are rules. You have to create object and access. But this keyword cannot be accessed in static. I think you cannot access. This will give an error only. This is correct. D.C is correct. But this .c will give you error. You can't use it only. It will not allow you only. See, this is error. But this one is correct. D.c. Initially it will be 0. Later on I can print the value of this. I cannot use it there. Value of C is, I cannot use this. Are you following now? I cannot use this keyword in main method because it is static context. Now rest all code, you focus on the last output now. Value of C is 3. Understood now? So now this object gets created. Okay, then can I execute hello world without the main method? A very simple program now. Shall I go to the next program? You can try do R&D on this. Class hello without what? Main. Not only hello world, you can write lot of lines of code. Save it. So what will the file name now? hello.java. Done. Compile it first. See this, I'll show you. D drive Is hello dot class present here? Some other hello dot class is there, not this one. So now it will overwrite. When I compile it, it will overwrite. Are you following now? Or you can give this name as any other name you give. So now compile it. The new dot class is generated. I'll run. So it prints hello world. But at the same time you are getting that error. No such method found error. You are getting this error now. No such method error. Why you are getting that error? No, main method is not there. Understood now? Are you clear this? So, but if I write main also will start execution. But we can print hello world without main. But we should not write the code like this. We generally use main method only for programming. This was on flaw up till Java 1.7. After 1.7 this will not happen. It will not execute. We'll see what happens because I'm using JDK 1.6. I'm teaching you 1.6. Okay. In 1.7 they have rectified this error. What they have done we'll see later. Understood? Are you clear with this? But till 1.6 without main method I can execute hello world. Here more examples are there on static. So more examples you see, the concept of static becomes more and more clearer. Okay, 2 more examples I'll give, some more. Now see, they'll ask again more things. I want to, see, the question is very tricky. Okay, answer is very simple. I want to find out how many objects of a class are getting created. We can't keep a track now. See, they'll be on class. When there's on class, you can create 1000 objects of that class. But end of the day in the program you want to find out how many objects have got created. So how will you write now? It becomes very complicated. But it's having very simple approach. All you do is, what you do now, you write class box. See now, you are creating so many objects of box. But you want to find out how many objects of class box have been created. So now you have to sit and count now. Box B1 is equal to new box, B2 is equal to new box, B3 is equal to, how many times you have to set new, that you have to count. But because sometimes you'll say you can't depend on the variables. Sometimes B4 is equal to B3. But actually there's only one object. Understood? So you can't depend on the variables. So to keep counting how many objects are, that's a very difficult thing. So if anybody asks you to write a program to count how many objects of a particular class have been created, you can take this approach. Class box, you write everything normally. Int W, int H, int D, everything you write normally. But declare one static variable now. Static int count. And what you do now, okay, in the constructor, you increment it. That's it. This dot W is equal to W. This dot H is equal to H. This dot D is equal to D. Count plus plus. Increment it. Okay, if you overload the constructors also no issue. You see, when the class is loaded and declared, 0 it is. When you create an object of box, 1. One more object you create, 2. But sometimes you can overload constructors. You might have a question, sir, I will overload. So that time what will happen? So this dot W is equal to W. This dot H is equal to H. D is equal to 10. We are hard coding. Here also you say count plus plus. Correct? Huh? Again you are having one more constructor, int X. So here also you write what? Count plus plus. Here you can write W is equal to H is equal to D is equal to X. In one line only you can initialize all the 3. W is equal to D is equal to H. X value will be given to D, D will be given to H, H will be given to. So here no conflict. You know about all this. Just telling about count plus plus. So now see. Tell now which object, means you want to create an object using which constructor you tell. I'll write first box B1 is equal to new box of 1, 2, 3. One new memory gets allocated, constructor is executed there now. What will be the value of count now? 1. Initially it was 0, but when the constructor completes execution it will be 1. Now box B2 is equal to new box. I'll call the second constructor. No problem. Now count has been changed to 2. I'll say box P3 is equal to new box and I'll send a value of 5. New memory, new object, third constructor gets executed. There also plus plus. So count is now 3. So wherever you want you print now. Box dot count. What will be the answer? 3. So you can get the number of objects. Supposingly, I'll write box B4. B4 is equal to B3. Is it getting incremented? No. So it will perfectly give you the number of objects getting created. So like this, there are many advantages of static variables. Okay, same value is required in multiple places, and you want to keep count anything, but same value. See, you want to access the value everywhere. It is possible. Yeah. Then many examples are there for static. I think now I given plenty. Yeah. Lastly, the final question now. Why is main declared as static? Examples over. Why is main method declared as static? Yes or no? Main method has to be executed without creation of an object. Main method has to be invoked here by the JVM without creation of an object. The only possible way without creation of an object you want to execute means by making the member as static. So that is why main is declared as static. So now if they ask you in interview, why should the main be declared as static? Because main method will be invoked by the JVM without creation of an object of the class. Main will be invoked by the JVM without creation of an object of the class. Yes or no? Your class is there now. Is that object created? The first class, Java demo, is the object created? Demo class object, is it created? No. So main method has to be executed by the JVM without creation of an object, without instantiation. That is why it is declared as static. Okay, so when we say Java demo, what the JVM does is, when we say Java demo, internally Java command will start the JVM. After starting the JVM, what happens? Demo.class is loaded into the JVM, and it will take this name only, what you are given here. That name only it will take, and using that name it will call only one member, main, no other thing. Supposingly if I say Java box, now what happens? Box dot main will be called. If that method is not found, no such method found error. Java hello, so it will take the same name it will take, and you call what? In that class, hello dot main. So whatever argument you give to Java command, in argument means the class name, it will take that name with main and try to invoke it. So this is the execution process. But this execution process is still in detail. In writing I'll give you. First what happens, second line what happens, in detail I'll give you. Provided I complete one more thing now. Two more things are there. Public and string args. In public static void main we have covered three things now. Main is the name of the method, and it should be small m only. Void is the return type of main. It cannot return any value to JVM. Static, why it is declared as static? Because it has to be invoked by the JVM without creation of an object. Okay, so still two more things are pending, public and string args. Once I complete those two, then I'll give you a detailed explanation about how the JVM will execute your first class. Understood? You don't have to worry too much about that. Just info it is. Okay, but to give you info, I need to make you understand what is string args, what is public, and then I can teach you all that. Yeah? Okay, but anyway, main will go on creating other objects. Are you noticing now? That will start off, main will start creating other objects. Other objects will have the handle like this. Reference variable, your reference variable will be referring to the objects, and the reference variables are used to work with the objects or complexity of the object. Now what is object? Object is nothing but code coming into existence. Only one object which never get created is the class which contains the main method. One object which never gets created 100% is the class which contains the main method. Sometimes we might create when in your class, in the class which contains the main method, okay, if you are having an instance member and that member you want to access here, you have to create the object. That's a very rarest of the rare scenario. Rarest of the rare scenario. And if you are writing code like that, we don't think it's a good code. We developers, others will think what? You're writing a bad code because you're jumbling up all the code inside that class itself. It would have been ideal for you to write that code in some other class. Yeah? So any other questions now? All topics clear? So understanding static void main now. To make you understand what is static void main, we have taken nearly 1.5 months. Still public and string args remain. Understood? But you think what? Public static void main is so simple. These are your problems. Because you think like that, you think it is simple. That is the reason it's very difficult for me to teach. You think it is difficult and come, I'll teach you definitely. Because you'll sit with open mind. Okay, I want to learn, I don't know anything, I can teach you. But before in hand only you come and say, I know everything, what will I teach you now? Understood? That is your overconfidence, which will kill you. Do not come like that, because now very important topics will start. So almost all we have completed with static. If there are any other topics in the next session, I might tell you if I have. Okay, I think I have completed everything related to static. Or if you have any questions also, you can bring it to tomorrow's class related to static. While programming, if you get any doubts and all, you can get the doubts. I'll type and show it to you here itself. Understood? But almost all we are done with how to write a class now. And now I'll put the final summary now of how a class will be written. Shall I clear all this? Oh, still it is not over. I think one more member is there. Our instance variable can be of type what? User defined type also. Till now our user defined data type has not been used as what? Instance variable, which I'll cover, and then I'll discuss the final members of the class. So, but a class can have what? See this, a class can have what? Just notice. A class, members of the class now, what all it can have? Just I'll highlight it now. Class is on big subject, man. Class is on big subject, very big subject. The members of class, notice now. Class, it will have a name, leave that. But the members, you can have variables. Sorry, which one? Yeah, variables you can have. Now these variables can be of two types, static and instance. Again, the static members can be primitive type or user defined type or reference variables. User defined type means reference variables, which I have not covered still now. We'll do it now. It's very easy now. In one day we can finish it off. Same instance variables also can be of type what? Primitive. All the instance variables we have seen now, they are of type primitive. Class box, int, wh&d, they are primitive type now. We'll see of user defined type also. So instance variables can also be of type user defined type or reference variables. So just see where we have to reach now. Then we can have blocks. Blocks can be what? Static block, instance block. It's a very simple story which we completed. Then you can have what? Constructor. You can overload. That's your wish. Okay, but these are the members. You can overload. Then you can have methods. Again they can be what? Static method, instance method. That's your wish. Again you can overload, all that will happen. Okay, see, constructors can be overloaded. Same as static methods also can be overloaded. Same instance methods also can be overloaded. But when you overload, you know that when the functionality is similar. Okay. Then if you are interested, you can have something called as inner class, which I'll be taking later. So just identify the pending topics. This I'll finish off. From tomorrow I'll be covering this only. The instance variables and the static variables can be of type user defined type. Tomorrow I'll be covering that. So inner class is there. Again inner class can be what? Static and instance. We'll be seeing later, not now, immediately. Then last member what you can have is overriding of finalize method. This is how a valid class is going to be written. Understanding what a class is? What is a class? Tell now, definition. So your definition is where practical class is what? You see this. In interview go and tell what is a class means. Rewind and play same old topic. What is a class? I don't know what you will tell. It's a logical construct that you will tell. Why do you use it? It's a logical class. When do you use it? It's a logical class. Rewind and play same answer, they will not select you. Okay, what is a class? Now it's simple. It's a user defined data type which is used for implementing oops. Understood? Then there are more info I have to give still about class. This is only one part I have explained to you. More I will be telling you later. What's the advantage of using a class? Reusability and avoiding complexity. When do you use it? This answer is a big one, which I'll be telling you later. When do you use a class? Okay. Why do you use a class? These are still pending answers or questions which I have to give you. I'll address it later. Okay. So don't rewind and play and give the same answer every time. Understand the interviewer's question properly. Okay. Slowly you'll understand his question. So after understanding the question, then give the answer. So you'll never understand his question. Whatever question it is, rewind and play, you'll give only one answer. You know tape recorder, no? It doesn't know anything. Simply rewind, play, like that your knowledge is. That is why you don't get selected in any interviews. Clear? Okay. Do you have any questions in this today's class now? Some things are pending. I'm not saying no, it's over. Okay. But this is how a class will be designed. We are progressing with that. So once class data type is over, then we'll progress with subclass data type. Then we'll go with abstract class. Then we'll go with interface. There also same members will come. So practice in one data type neatly. Other data types will be definitely easy for you. There also abstract class will be there. There also interface will be there. Same topics, same members. But now question will be why to use abstract class, why to use subclass. We'll see it. That's not a big thing. When you understood so many things, those things are very silly for you. Yes or no? Top level engineers, and you know what a class is and you know what an object is. High quality engineers, correct? So obviously they are very simple topics too. So you don't have to worry about all that. So shall we close the class now? Okay, that's it.